A warm welcome to everyone who has been affectionate enough to join us this evening and become a part of the first and inaugural session of INSEES Invictus.
A Nuteric module by the Electronics and Instrumentation Department of NIT Silchar, or rather just abbreviated as INSEES.
My name is Saurav Suman.
And I am Nehashmita, and we have been bestowed to be your host for the evening.
Taking the event further, we would like to express our gratitude to the faculty members present here with us in this meet.
In order to formalize this articulation, it is important that we address the eminences. So, beginning with Mr. Manas Bera sir, the head of department of our branch, a person extremely invested towards the welfare of NIT Silchar and driven to make and witness us excel in instrumentation sector. Thank you, sir, for being here with us.
Next up, we have Mr. Lalu Sevan sir, the individual who has had an up-close experience of being a student in NITS while pursuing his degree. As a doctorate of philosophy from the electrical engineering branch, thus understanding our grief, we hope to be called in our campus soon. With this, we would like to have the session open with some kind words from our head of the department, Manas Behra sir. So, sir, the stage is all yours.
Good evening to all of you. And in behalf of Department of Electronics and Instrumentation Engineering, special welcome to Mr. Udit Ojha, who is our guest speaker today. And I'm very much glad that INSEES has come forward and they have started the doing program like this, where our existing students will be motivated, and also with this program I hope that the bonding between the students and our alumnus will be stronger.
Now, moving forward and emphasizing upon the name of our module, INSEES Invictus, the word Invictus means undying or undefeated. It denotes and demonstrates the triumphant spirit of INSEES. We strive to have a earn and hunger in our heart to learn and help serve our nation and the society for the greater good. Thus, embarked upon these thoughts, we would like to welcome our speaker and mentor for the evening, Mr. Udit Ojha sir.
Personage who has done it all and been credited with scads of meritorious acclamation.
Rightly said Saurav. Sir is a fortwhile scientist, PIC officer at the Bhava Research Center of India, pursued his BTech from Electrical Engineering from our very own NIT Silchar, the class of 2016.
His various auxiliary endeavors include him being an assistant manager in Tata Motors and as a junior engineer at the Power Grid Corporation of India.
Resilient, cooperative, and benevolent are some of the key adjectives defining him.
My name is Udit Ojha, as all of you know, and I am working on the post of Scientific Officer C, which is the entry-level post for the scientific cadre of officers in Bhava Atomic Research Center. And this comes under the Department of Atomic Energy, Government of India. And so, moving to the next slide, actually, I'll tell you something, a very brief overview of what BARC is. So it is a unit of Department of Atomic Energy, as I have already told you. So BARC, which was earlier called as Atomic Energy Establishment Trombay. Trombay is basically the area where this establishment is located. So as all of you know that this is a nuclear research facility and the headquarters are here in Mumbai itself, and it was founded by Dr. Homi Jahangir Bhabha, on whose name this institution has been named. And as you can see, the logo clearly outrightly says that atoms in the service of the nation. So, and Rashtra ki seva mein parmanu. So we are basically using the atoms to do all those tasks which are whatever research we can carry out using atoms and subatomic particles, and then so the different fields, the different applications of nuclear energy include, and the peaceful applications, moreover. Not the applications can be wartime applications, which we never want, which no one ever wants that there should be a war. But although there are all the countries, including India, do have envisaged and are prepared for such situations and do use atomic energy for building upon their arsenals of weapons and all. But still, we are mostly concerned about peaceful applications of nuclear energy. So, like theoretical design of reactors. Reactors are nuclear reactors. Then computer modeling and simulation, risk analysis, development and testing of new reactor fuels and materials. Since reactors are, they have a lot of nuclear reaction which is happening inside them. As some of you might be aware that nuclear reactions are basically of two types, fission and fusion. Fission involves breaking of a very large, heavy nucleus into smaller fragments of lower atomic mass, and fusion involves combination of two lighter atomic nuclei and they combine and form a bigger nuclei. So these are the reactions which take place. So there should be certain materials should be designed in a certain manner so that they can withstand this new radiations which are developed there, beta radiations, gamma radiations, neutron flux radiation, all these kind of things. Then spent fuel reprocessing and safe disposal of nuclear waste. So since nuclear is a very this nuclear radiation is a very useful, but at the same time if it is not, if it goes out of the limit, then it can be harmful as well. Although the systems are built after a lot of study, deep study, detailed analysis. So it has never so happened in India, such word that never such accidents have happened. And even in the world, nuclear has a quite clean record. The last biggest disaster was in 1984, that was in Chernobyl. And one more happened in 2011 in Fukushima in Japan. But still, like in India, this atomic research and this nuclear research has quite progressed well and has built upon the experience it has gained from the outside, from the nuclear programs of other countries. So we have kind of made this quite safe here, and so that nothing unanticipated happens. So then there are some other things like applications in industries, isotopes in industries. I mean, sorry, applications for isotopes. So these isotopes, which are used in which are used in health, food, and medicine, agriculture, and environment. All of you are aware that cancer is it's a fatal disease and a very long-term disease, chronic disease. So cancer is one of the fatal disease and chronic disease. So this disease actually is treated through nuclear radiations. All these machines which are there for treatment of cancer, there is a radiation therapy which is carried out. So this is a societal application of the atoms, which I told you that these atoms are being used not just for war applications. That is a very small part, but these societal applications which are for the betterment of the society. So and in the agriculture field as well, this research of nuclear related research is being used to increase the shelf life of the agricultural produce which is there, to increase their shelf life, and also to get better quality of crops, high yielding crops. Then there are some applications as well as in environment, as in there are environment monitoring labs of Department of Atomic Energy, which actually monitor the amount of radiation. See, the sources of radiation are not just on the Earth itself, but radiations come from the cosmic space as well, from the outer space. So those radiations also need to be monitored, and they need to be documented so that no one receives the radiation levels at a higher level out of the tolerance limit. Then there are some other things like accelerator and laser technologies, electronics, instrumentation, material science, environment, and radiation monitoring. Radiation monitoring, as I already told you, material science, environment. So I will move to the next slide, which actually I have described my role in my words that and what I do at BRC. So I am currently working in the reactor operations division at BARC, Mumbai. This is the division operating one of the largest nuclear research reactor in the world. The name of the reactor is Dhruv. Although in English we are using Dhruva, but it's actually called Dhruv in Hindi. So Dhruv as in the north, the pole star, we call it Dhruv Tara. So the reactor is named after that star. It's called Dhruv. It's a 100 megawatt rated capacity reactor. The rated capacity in the reactor, it's defined in thermal capacity, and there is electrical capacity as well. But this is a research reactor. This is used for research. Its main mandate is to carry out research. And there are other reactors which are used for generating power, like Nuclear Power Corporation of India Limited, which is another unit of DIE. They generate power using nuclear fission. So those reactors have an electrical rated capacity and a thermal rated capacity as well. But our reactor does not generate electrical power in the reactor in which I work. So the core competencies include operating the nuclear reactor, as in maneuvering the power, as in the startup, shutdown, change in operating power, looking after various operational aspects, detailed study on all the reactor systems and subsystems, maintaining and ensuring operation within nuclear and radiation safety limits. Deliverables of the reactor include various radioisotopes used for medical and industrial applications, neutrons from the reactor used for carrying out of various experiments, testing new types of fuels as in nuclear fuels, radiation detectors, sensors, etc. So, and my work is not just restricted to my domain of electrical engineering. I have done my engineering in electrical, but it's a highly multidisciplinary job, and it demands thorough understanding of other fields such as mechanical, metallurgical, chemical, electronics, instrumentation, radiation safety related aspects, among others. Even nuclear science, which I haven't mentioned here, but nuclear science as well, nuclear physics, in particular reactor physics, is very uh, it's a basic. We have to understand that to operate the reactor. So these are some views of my workplace where I work. So this is the reactor in which I work. On the left side, the image which is on the right side, and you can see two buildings in that. One is a dome-shaped structure, and the other is a cuboidal-shaped structure, yellow colored. So that is the Dhruva reactor where I work. On the right side of that is the Cyrus nuclear reactor. So that reactor is presently shut down, and all of you must have heard about the Pokhran nuclear tests, which India conducted 2 times in Pokhran. And there also some of you might have watched that movie which had come some 2-3 years back about that Parmanu. So that test was actually carried out by BARC itself. So that was to assert the country, assert to the world that we are also capable of maintaining a nuclear arsenal, and we also have nuclear research facilities and capabilities, and we are also progressing very well at par with the other developed countries. So this is the view of the my workplace of the reactor, and all since I am not this is a highly secure place. This image also I have actually taken from the official website and from the public domain. Otherwise, we are not allowed to carry our own devices inside, like mobile phones and laptops. And see, this is a representative image of the place where I work. Actually, this is the control room. This is a control room. I have just borrowed this image from Google, but yeah, this is the control room where basically I work. And these are the different. It looks similar to this. These are the different systems which are there. Since the reactor is a very complicated system, and it has various subsystems, so all of them need to be monitored. All of them need to be the operators and the officers have to be aware about the status of the systems. There are various sensors, various instruments. There is a very important role which instrumentation has got to play in the operation of these reactors and in the operation of various other nuclear facilities. So this is a control room, and this control room has different devices which help in monitoring, and they are in constant communication with the instruments which are deployed in the field. So is the degree of engineering degree, is it enough? I mean, is it just enough to get a job, or what else is needed? What else is needed so that the employability of engineers who are graduating can be augmented? So this is employability augmentation. I'm sorry. So see, the rapidly changing industrial environment and emergence of new technologies. As we all know that every day there are new developments which are taking place. There are various research which is taking place all around the world, including in India as well. So this Industrial Revolution 4.0 has already kicked in. Already some industrial revolutions have took place in the past 2-3 centuries, starting from the 1700s when the Industrial Revolution 1.0 started in the West, in the England. So after that, right now we are going to the Industrial Revolution 4.0. So this requires much more than from a core engineering degree. Much more is required. Although core engineering knowledge is a cornerstone, it's a very fundamental. It helps in building the basics, but a plethora of other skills need to be acquired, by an engineer to render oneself more appealing and valuable in the professional arena of the day. So the complex problem solving and critical thinking, professional and ethical behaviors to environmental awareness. these are some of the things like critical thinking one should have, professional and ethical behavior, complex problem solving. See, just by I am an electrical engineering. There are instrumentation engineers here. There are electronics engineers. So just by knowing knowing the how to solve the circuits and how to, uh, connect sensors and all these things, which are actually, our core part of these engineering fields. But we need to, know other things so that these other things, some of the things which I already highlighted, like these things, when we actually enter into, the professional field, into the professional arena, so see, there are new technologies like blockchain, which everyone knows, AI, machine learning, and big data, deep learning, etc., which have to be, which have led to them being ubiquitous. So these things are spreading at such a fast rate that they are almost everywhere. Like there was a phase when computers were, in the 70s or 80s, when computers started to be used, they entered each and every aspect of the life from all the sectors. So they became ubiquitous and all omnipresent everywhere. So similar is the stage for blockchain, AI, ML, all these things right now. That these things are taking over almost all the fields, and the domain of engineering is no exception to this. Even these things are used in the domain of engineering as well. So electrical, electronics, and instrumentation fields of engineering are also, these new technologies are emerging, and they are finding uses in these fields as well of, the core engineering fields. So we see there are so many devices around us, and these devices are, the population of these devices is increasing day by day. IoT, which I have not mentioned here, IoT is Internet of Things, which is the Internet of there have been three or four internets, like Internet of machines, Internet of people, and now this is the Internet of Things, like the things of daily life which we use, like even our the electricity bulb which is there, the light bulb which is there, or something from a microwave oven or any other things. They all these things are connected they are connected on a common network, and they can communicate with each other to, make the life of the users better, to make the life of the users, us humans, better. So this is the emergence of these new technologies. So the engineers, apart from their core engineering, need to, gather skills, need to master in these fields as well, so that they can be more employable, and that can increase their chances of, getting a good placement, getting a good job, and they can prosper in their careers as well. Another key skill today is interdisciplinarity. As I already said, that my field itself is quite interdisciplinary in nature. I need to, understand the concepts of other things apart from electrical, apart from my core branch. I have to understand. So that actually allows for synthesis of ideas and characteristics from many perspectives. Since we can, see from the perspective of others as well, from the other fields, from the other, other fields of engineering, and even other fields, from the financial perspective, economic perspective, from the social perspective. Okay. So with the ever increasing competitiveness in the industry, and engineering in particular is expected to know more than just electrical, electronics, instrumentation engineering, which is the core engineering knowledge. So that's how this has become a norm nowadays. This is a normal. This is the new normal which everyone, has to get into. For instance, an electronics instrumentation engineer making a biomedical instrument should have the knowledge of the medical field as well, because they know that what, the instrumentation people, and even me, electrical and electronics guys, know that, yeah, this is an instrumentation amplifier is there, or there is a sensor which has to be connected. But, they will have to know, like, exactly how we have to integrate it with the medical field, how it has to be integrated there. So for that the knowledge of that field as well is very much needed. Like for me, in nuclear reactors, the instrumentation, electrical, electronics find, there is a very wide use of all these technologies. So actually need to understand the other things which are there. So then only that successfully integration and successful working of the system can take place, when one, the engineers have all this knowledge, and they can integrate, and, they can successfully implement those systems. Then apart from these technical skills, there are some soft skills, apart from the hard skills which I said, so which are very much imperative and very much needed for a person to be successful and impactful. Engineers are no exceptions again for that. Communication skills, the ability to explain the others one's ideas lucidly, that is very clearly, does count when working with people from varied academic and professional backgrounds. Like everyone will have to do that, because wherever we go and work in an organization, there will be people from different backgrounds. Not everyone will be engineers. There will be people from the other from the HR, from the legal side, from the commercial, financial accounts, and all these things. So an engineer has to have those skills and so that they can effectively communicate there. Even something if some technical jargon is there, so they have to simplify those things and explain it to the other people in order to achieve the aims, because everything is a teamwork. So to work as a team, to make a team successful, such communication skills are a prerequisite. Then emotional intelligence is another must-have, which encompasses presentation and negotiation skills to cope with the stress. So these days people are there are many people, they are overloaded with work, or even if they are not very much loaded, but sometimes people come under stress and they have performance pressure, peer pressure, and different kinds of pressure. And specifically in the light of pandemic, when people have lost jobs and there is a widespread livelihood loss which has happened. So emotional intelligence will actually help in coping up with this pressure, and other skills like negotiation skills can also we can improve by the help of this. And again, I have put team, ability to work in a team and capabilities such as strategic planning, risk management, and critical thinking. Earlier, these things used to be more or less in the management studies, but these days, even engineers have to know this, because these days engineers have actually become not just technical people; they are techno managerial. The roles everywhere are techno managerial. The organizations are expecting that that the one they are recruiting, the engineers, they should be well adapt and very much skilled in carrying out these managerial roles as well, from managing people and managing resources, managing manpower, and managing the capital which is there. So these skills are very much pertinent and very much they are required. So I'll go to the next slide. These are some of the guiding philosophies and principles which I have mentioned. Although some of them are very common, but I have still written like complacency leads to accepting one's situations and makes way for hesitancy to work for betterment. So, in my particularly, if I see this in the light of my professional career, till now, what progress or whatever little progress I have made. So, I have worked in different jobs, from Tata Motors, from to Power Grid, and then to BRC. And in the meanwhile, I also got into some other jobs as well, into some other for masters as well. But I have never been complacent, because if if in some place we get complacent, if someone gets complacent, then that will actually block the way for future progress and for betterment. And there will be an hesitancy, there will be a doubt in the mind that, we cannot progress much more than that. It's not, I'm not, I mean, this is not that I am against stability, that I'm not advising that someone, if they are at one place, they should be there, they should learn from that place, from that organization, from that institution. But still, I believe that a progress is change is the change is the normal, change is inevitable. So this change needs to this change needs to happen frequently, not very frequently, but yeah, it needs to happen, so that ultimately we can get knowledge from various fields. So, and then for learning to happen, a conducive environment is a sine qua non. Sine qua non actually means prerequisite. One needs to accept the other person as the teacher for constructive transfer of thoughts, wisdom, and knowledge. In particular, I would like to highlight that I actually was working in Power Grid as a junior engineer. So there, I was at a lower role as compared to the other guys who had similar degrees in BTech, and they were working as my bosses or as my managers there. So there, sometimes if someone is working like that in such a situation, and if I get into my mind that people are I am much at and working at a lower post, and they are working at a higher post, although we have the same background and the same capabilities. So that should actually, that I took it as a permanent, I took it as a temporary, thing. I went there for some learning and for some experience, which I wanted to gain. So if that learning cannot happen, if if such preconceptions, misconceptions exist in my mind, so there has to be a conducive environment for that constructive transfer of thoughts, wisdom, and knowledge to happen. And the toil in silence, let success make all the noise and pomp. So this is a very cliche quote again. And then accepting one's mistakes is the prerequisite to correcting them and puts one on the growth trajectory. So whenever committing mistakes. Even I have committed mistakes. Everyone does in their life at some point or the other. So yeah, once when we accept those mistakes, and that is the first step. If we don't accept that mistake, then anyone will be in a misconception that they have not committed any mistake as only. So and they will continue doing the same thing. So that is actually the prerequisite that will put someone on that will put the person on the growth trajectory so that they don't commit such mistakes in the future. And then this is the last one, never settle. So this is my this is I believe in never settling because I have been going from places to places from different from one sector to the other, manufacturing sector to the transmission sector, electrical transmission power sector, which I wanted to work in, then to the nuclear sector, and then maybe in the future as well I will move to some other sector to after spending considerable time in the ARC. Uh, and so I think that always we need to strive, thrive, and be intrigued for the better and the new realms of knowledge, wisdom, and experience. So this was all from my side.
Thank you, sir, for all these deep insights from your experience into like you have shared all your experience from like being an assistant manager at Tata Motors to being a junior engineer, which you said that was something being putting yourself at a lower level, but that was just an experience you had earned, and that long but deep insight about the transition you have had from being at two places and currently you are right now at BARC. So thank you for that. And I actually liked that point, like the engineers are not just supposed to be technical, but techno managerial. I would say that word. If I'm saying it right or wrong, that would be
Yeah,
another.
correct.
Thank you for all that.